So let's discuss some properties that we have with the matrix addition and some multiplication stuff. So you still have the commutative property even though we're dealing with matrices. So the commutative property says the order that you arrange your matrices in doesn't matter. So if you want to say A plus B or B plus A, it's going to be the same thing. Similarly with the associative property, it says if you want to, you can combine B and C first and then add A, or you could add A and B first and then add C. The result's going to be the same. And then we have this property that's associated with the zero matrix. So a zero matrix is a matrix in which every entry is, guess what? Zero. Goose egg, right? So if you were to add the zero matrix to A, or add A to the zero matrix, you end up with just A. It doesn't change anything. And we know this, right? If I say I'm going to add 0 years to your life, nothing changes. If I add $0 to your bank account, nothing changes, right? Adding 0 doesn't change anything. Just like multiplying times 1 doesn't change anything. Now, if we have scalar multiples here, so we're using K and H for the scalars, it doesn't matter the order in which you do the operation here. So if I want to do H times A first, and then multiply times K, I can. Or I can multiply the two scalars first before I distribute that to all the entries in matrix A. Or in the one that I have below that, if I have the sum of two scalars, I can add them, then multiply, or I could basically distribute the matrix A to both of these and do K times A, H times A, and then add those guys. And then you basically have what amounts to the distributive property down here. So you could add matrices A and B together first, then multiply times K, or you can multiply each of them times K and add the results. So let's look at these two matrices. Okay, both of these guys have the same dimensions. They are both 3 by 2 matrices because you have 3 rows and you have 2 columns. So that means that we can do addition and subtraction. Now, when it comes to multiplying, like what we have here for 4A, it doesn't matter what the dimension is because you're just dealing with matrix A. So 4 times matrix A just means taking all of these entries. So take each entry here and multiply everything here times 4. That's all that it says to do. And you might be going, can it really be that simple? Is that all that needs to be done? Yeah, that's all that needs to be done. So it means we have 8, negative 16, negative 24 for the first column, and then 28, 20, and 4 for the second column. That's it. Again, don't complicate things. If I have 1/3 times B, that means I'm going to take everything that's over here and I'm going to multiply times 1/3 or divide by 3. So let's just kind of do that again like we did before. I'm going to write my entries. And then I need to divide everything by 3 or multiply times 1/3. So divide by 3 for all of these. So what is my new matrix now? Well, that's -3, +5, +1. +4, negative 1/3, and +3. That's it. Now this last part here, 5b minus 2a. So we need to do it in that order with the subtraction. And we need to make sure we multiply all the entries in B times 5 and all the entries in A times 2. So let me do this. So 5b minus 2a means 5 times b. I'm just going to copy this guy right here. So copy, and we're going to move him to be right there. Minus 2. Let's come back up here and grab matrix A. Whoops. And move it right here. And so now we can perform each of these operations. So multiply everything in the first matrix by 5. So we have negative 45, 60, 75, and negative 5. And then 15 and 45. And we're going to say minus. So this guy over here, we're going to just distribute the 2. So that's 4, 14, negative 16, and 10, negative 12, and 2. All right, so make sure that I multiplied everything times. Where did I get 16 from? Wow. I'm just out. I don't know where I came up with that. That's negative 8. What was I thinking? Do you know? I have no clue. Let me just double check this. So 4, 14, negative 8, 10. Okay. Yikes. And now we can finish this off by doing the subtraction. Again, pay attention to your signs. Now, what you could do is that you could go ahead and turn this minus into a plus and then change all of the signs in here. So make this a minus, that becomes a plus and a plus, minus, minus, minus. And then we can just add these guys, right? So you've got negative 45 and negative 4 is negative 49. 60 minus 14 is 46. 75, and now it's a plus 8, so that's 83. Negative 5 and negative 10 is negative 15. 15 and 12 is 27. 45 minus 2 is 43. So this should be our answer. But you know what? Evidently my brain is not clicking the way that it should. So we're going to check with the graphing calculator. Now, it's going to take us a bit to do this because we have to go to the matrix menu and we have to edit these guys. So this first one is a, let me scroll back up. I want to make sure that I'm getting the right stuff here. So we have 3 rows and 2 columns. So the entries are 2, 7, negative 4, 5, negative 6, and 1. So that's A. All right, so let's go back to the matrix menu and edit matrix B, which is also a 3 by 2, with entries of negative 9, 12, 15, negative 1, 3, and 9. We wanted to do 5 times matrix B, so 5 times matrix B minus 2 times matrix A. And is this the same thing that we have? And yeah, it looks to be the same thing. Negative 49, 46, 83, negative 15, and 27, 43. Gotta watch out for your careless errors. Just like, I mean, why did I ever say 2 times 4 was 16? Maybe I was thinking 4 squared. Who knows? But you gotta watch out for that stuff. Watch out for your signs, all the little things. But you take your time, and it should be okay because you're really just having to do, kind of distribute a number. Can I multiply every entry times a number? Yes. Can I add or subtract 2 numbers? The answer should be yes. If you can do all that, you shouldn't have any problems.